Today we're going to start talking about how these, let me start over. Last time we talked about how these atoms form ions, how based upon the number of electrons in the outermost or valence shell determines whether it determines that the metals give away electrons to form positive ions with charge equal to the number of electrons lost. Nonmetals are going to take electrons to fill out that outer shell to get to 8. Having a negative charge equal to the number of electrons that they took. So looking at aluminum here, 3 outer shell electrons. I'm going to go back to my 2 big questions. Are you closer to 0 or to 8? So in this case, 3 is closer to 0. So aluminum will give away those 3 electrons, forming a charge of positive 3. And once again, we're losing electrons. We're losing our negativity. We now have 3 more positive protons than we do negative electrons. So we end up being positively charged. For fluorine here, fluorine has kind of hard to see, but there's 2, 4, 6, 7 electrons. Make that guy a little bit bigger because of the light. 7 outer shell electrons. We get that because that's the column it's in on the periodic table. It's the number we wrote in. 7 is it closer to 0 or closer to 8? Well, we can give away 7 to get to 0 or take 1 to get to 8. So let's take 1 electron. We now have 1 more negative electron than we do positive protons. So fluorine ends up with a charge of -1. So here's why this is important. So forming ions, these atoms aren't happy having incomplete outer shells. They want to fill them up somehow. So we can either give away electrons to reveal the full outer shell that's beneath it, or we can take electrons to complete the shell we're on. And that makes them happy. However, now that they're charged, they can't be by themselves. We know this because like charges repel each other. Opposite charges attract. So really we're going to start looking at what these things do. How do they make themselves happy? Now they're charged, but in a group, they don't want to look like they have a charge. So when they start forming ionic bonds, bonds between ions, they're going to do so in a way that all of the charges cancel out. And a couple ways to determine it. We can do this algebraically. So for instance, we have aluminum with a charge of positive 3, fluorine with a charge of -1. So we could come through and go, we have positive 3 times something, and then we have -1 times something as well. Let's even go x and y. All right. Now the big thing here is we want down here to be the same value of number, we want them to be the same number, just opposite signs. And since we can't have a negative number of atoms, these are going to be positive, so I'm going to end up with a positive number here, negative number here. Now we're going to look at trying to find the least common multiple here for 3 and 1. So the least common multiple of 3 and 1, the lowest number, I can take both of them times whatever to get to the same number, is 3. Since we're working with 1, that gets to be really easy. So positive 3 times what gets me 3? Would be a 1. Negative 1 times what would get me to -3? Well, that would also be, I did that wrong. So my x is 1 to give me positive 3. My y then becomes 3 to give me -3. Now my charges are the same. If I have 1 atom of aluminum, 3 atoms of fluorine, positive 3 is my total charge for my metals, -3 is my total charge for my nonmetals. Those cancel out to 0. So my compound here will be 1 aluminum and 3 fluorines. Now if you notice, I'm not going to put a 1 there. If there's no number here, it's implied it's a 1. And then my 3 I write as a subscript, which means it's smaller and down kind of beneath the fluorine there. So that's the algebraic way to look at it. There is an easier way. It's got a little bit of a dance to go with it, but you can't see my feet, so it's not as cool. But really, it's just the write the charges, you crisscross them. Write the charges, crisscross. Write the charges, crisscross. Okay. Once again, you write the charges up by the elements, and then you crisscross them. So looking at aluminum and fluorine again, I'm going to write them a little bit closer to each other. So I wrote the charges, +3 and -1. Hoping that's visible. And now we crisscross. Now when we crisscross, they're going to lose their signs. That means that 3's going to go down there. this 1. I'm going to go down there. Separation between the negative and the 1. So this tells me I have 1 aluminum. That tells me I have 3 fluorine. So doing a crisscross method, doing it algebraically, I still get the exact same answer. Now let's say that we're working with calcium and oxygen. Calcium is in column 2, 2 outer shell electrons, closer to 0, closer to 8, it's closer to 0. It'll give away 2 electrons from return to positive 2. Oxygen is in column 6, closer to 0, closer to 8. 6 is closer to 8, so oxygen will take 2 electrons to get to 8. It's taken on 2 negative electrons, so the charge is negative 2. So in this case, crisscross method, the 2's come down, but if they're the same number, if you can simplify them at all, like 2 and 2, 1 and 1, even if it's 2 and 4, you can simplify those down. So in this case, I can divide, so it looks like I'd have that, but I can simplify this, divide both of these by 2, I end up with just CaO, just 1 of each. This tends to be more correct when you start looking in college textbooks, stuff like that. So just keep that in mind. So once again, write the charges, crisscross, and you lose the sign when you crisscross. Like I didn't bring the positive down or the negative down. So just keep that in mind. So that covers, so right now we've learned how to form ions. We're learning how to determine the base ionic compound formula, the base chemical formula for these things. Chemical formulas, once again, they just tell us the number of atoms of each one in a base unit of that compound. Next time we're going to talk about polyatomic ions, so that'll be fun. I think. No, we're going to do naming, then we'll do polyatomic ions, just to give you a heads up of what's coming up.